Hello, today I'm going to be going over number 15. The front 1.2 meters of a 1,400 kilogram car is designed as a crumple zone that collapses to absorb the shock of a collision. If a car traveling 25 meters per second stops uniformly in 1.2 meters, A. How long does the collision last? B. What is the magnitude of the average force on the car? And C. What is the acceleration of the car? Express the acceleration as a multiple of the acceleration of gravity. Okay, so the first thing we're going to do is write out our givens. So we know that the mass of the car is 1,400 kilograms. We know that the car initially is at 25 meters per second, but it's going to stop 1.2 meters from its original point, which is here. So that means the final velocity is going to be 0 meters per second, and then the displacement is going to be 1.2 meters per second. What we don't know is the time, and we don't know the acceleration. For part A, we want to find the time. So first we have to find the acceleration. And to do that, we have to use kinematics. So when you plug in the values, you get negative 260 meters per second squared. Remember that final velocity is 0 meters per second because our car is eventually going to stop. So that's why we plug in 0. And then we're going to use final velocity equals initial velocity plus acceleration times time to find the time. And we're going to use the acceleration we just found to find the time. Okay, so for part B, we want to find the average force. But on the question it says we need to find the magnitude, so you have to put absolute value marks around mass times acceleration. So we use the mass they gave us and then the acceleration we just found, and we get 3.65 times 10 to the 5th newtons. For part C, we're going to find acceleration as a multiple of gravity. We're going to take our acceleration and divide it by negative 9.8 meters per second squared, and we get 26.6 times gravity. And if you want to check this, you can plug in g and you get the acceleration.